Welcome to the ProTicker Deep Dive. You're interacting with them probably right now, or you have been today. Maybe you're holding a smartphone, perhaps driving an electric car, or you've seen those huge wind turbines out at sea, all that modern tech. It relies on this specific group of 17 metallic elements. We call them rare earths, or REs. They're sort of the hidden engine driving this whole global energy shift.
Exactly. And that's why they're not just some obscure commodities anymore, right? They've moved center stage. They're right at the heart of geopolitics now and this massive economic change that's happening.
And we're really at a fascinating point right now, late 2025. Prices for the really important ones, the magnetic rare earths, they're way up, like 40% just this year.
Yeah, and stock valuations for companies in this space, triple digits in some cases.
Yeah.
Plus, you've got governments, especially in Washington, pouring billions into securing their own supply chains.
So our mission today really is to unpack all of this. Why are these, fairly obscure materials suddenly deciding who wins and loses in this global race for clean energy?
Well, it starts with understanding why they're so indispensable. The whole global move towards electrification, it's structurally impossible without REs. We're mainly talking about four key ones here, the magnetic rare earths.
Okay, which ones are those again?
Neodymium, praseodymium, dysprosium, and terbium. These aren't just like raw materials. They are the actual chemical ingredients. They give you the lightweight, high-performance efficiency that modern tech, especially motors, absolutely needs.
Got it. Okay, so let's dive into the demand side first. What's driving this huge scramble for supply? You mentioned EVs earlier.
Yeah, EVs are definitely the biggest piece of the puzzle, the single largest demand driver, no question.
Why are they so critical for electric cars?
Well, over 90% of the EVs rolling out now use these things called permanent magnet traction motors. And the magnets themselves are made from NdFeB, that's neodymium iron boron.
NdFeB magnets.
No,
Okay.
they're essential because they provide that compact size, the efficiency, the high torque, basically everything you need for decent EV range and that quick acceleration people expect.
And how much are we talking per vehicle?
It's significant. Each EV needs somewhere between 1 and 2 kilograms of these rare earth magnets.
1 to 2 kilos per car. Wow. And the sales numbers are exploding, aren't they?
They really are. Global EV sales, they're forecast to hit over 21 million units this year, 2025, and then accelerate even more, maybe 34.5 million by 2030.
That's just massive structural growth year after year. It puts incredible pressure on getting enough of these materials.
Exactly. And EVs are just one part, albeit the biggest part.
Right. You also mentioned wind energy, especially offshore.
Yes, offshore wind is the other major pillar here, those huge offshore turbines. Many of them rely heavily on what are called direct drive permanent magnet generators.
And these use even more rare earths.
Significantly more, yeah.
Mhm.
Per megawatt of power generated, they use a lot more rare earth material compared to the older geared turbine designs. So they are intensely dependent on REs.
And that sector is also booming.
Locked in growth, pretty much. Global offshore wind capacity is set to expand something like 18 to 19% annually through 2026. This isn't just a short-term thing. It's tied to global green energy mandates. They need these materials.
So connecting this demand to the longer term, what do the projections look like?
Well, the overall demand for rare earths is projected to triple by 2035. That's big enough on its own. But if you drill down into those critical magnetic elements,
The ones for EVs and turbines.
precisely, the projections get, frankly, dramatic. Neodymium demand could jump by 700% over the next 25 years. And dysprosium, that's vital for magnets working at high temperatures, demand for that could soar by maybe 2,600%.
Whoa, 2,600%.
Yeah. I mean, these numbers really paint a picture of just how incredibly tight the supply situation is going to be. The margins are razor thin. Okay, so massive demand, critical need. But this all hinges on supply, doesn't it? And that brings us to the elephant in the room, China's dominance. That really is the core vulnerability, the systemic risk. China controls, 60 to 70% of the world's actual mining of rare earths, which is a lot.
But that's not even the main issue, is it?
No, the real strategic chokehold is further down the line. It's in the processing, the separation, and refining stage. Beijing commands a staggering 85 to 90% of global capacity there.
Can you break that down a bit? Why is refining the bigger hurdle? Why can't other countries just build processing plants faster?
Well, it's a huge technological and, frankly, environmental challenge. Mining is, relatively straightforward. You dig this stuff up. But separating and refining, that's like complex chemistry. These rare earth elements, chemically, they're very, very similar to each other. So teasing them apart into pure individual oxides like the NdPr oxide that magnet makers need is incredibly difficult. It requires huge investment, complex facilities, and it's notoriously difficult to get permits for because of environmental concerns, including handling naturally occurring radioactive materials often found with REEs.
So that 85–90% control essentially means China dictates the quality, the speed, the cost of the final ingredient needed for magnets globally.
Pretty much, yeah. And they've shown they're willing to use that leverage. We saw that clearly in 2025.
Right. Talk about that. What happened?
Well, in April, they brought in sweeping export controls. Suddenly, you needed licenses to export medium and heavy rare earths.
Okay, that's significant.
But then they escalated things in October. That was maybe the biggest strategic signal. They basically mandated that any foreign company exporting any product with even a tiny amount, over 0.1% of Chinese rare earths, needed government approval first. And they had to disclose who the end user was.
Wow. So global manufacturers basically had to ask Beijing for permission to sell their own products if they contained even trace Chinese REEs.
That's essentially what it meant. It forced companies worldwide to reckon with their dependence in a very direct way.
Although there was that temporary pause, right? The U.S. and Chinese presidents made that one-year deal in late October.
Yeah, a deal was struck, and China did temporarily suspend the most restrictive controls that provide some near-term breathing room for operations.
But it's just temporary relief.
Oh, absolutely.
Yeah.
Everyone in the industry sees it that way. The underlying strategic competition, that's not going away. It's a years, probably decades-long issue. You see analysis like from Goldman Sachs suggesting it'll take the West a minimum of 10 years to build up truly independent supply chains.
10 years minimum. Is that actually realistic? Or just political talk? That feels like a very long time when technology is moving so fast.
It really reflects the sheer complexity involved. You can't just, magic up these highly specialized chemical processing plants overnight, especially with the environmental hurdles. It underscores that this is a huge, generational, strategic undertaking, not something you fix in a couple of years.
And that realization seems to be driving this huge wave of government money, right?
Definitely. Securing these supply chains has gone from being like a business worry to a top-tier national security issue across the West.
We've certainly seen the dollars flowing.
Yeah, look at the U.S. Over $2.8 billion committed just from the Department of Defense. And that's on top of the incentives already packed into things like the Inflation Reduction Act and the CHPS Act.
And Europe's doing something similar. The EU has its Critical Raw Materials Act. They've set a clear target, source 10% of their critical mineral needs domestically by 2030. It's a major policy push. But maybe the most significant shift, market-wise, was the U.S. government stepping in to create a price floor, right? That seems like a game changer.
It truly is a paradigm shift, yes. The Department of Defense put over $400 million in strategic funding into a major U.S. producer. And critically, that established a government-backed floor price of $110 per kilogram for domestically produced NdPr oxide.
Okay, $110 per kilogram. Why is that specific number so important for people following this?
It sends a powerful signal. It says that strategic security now officially matters more than pure short-term market efficiency. By guaranteeing a price well above what China can likely produce it for, and definitely above where the market price settled around $67 per kilo recently.
Right. The U.S. government is basically subsidizing domestic production for security reasons. This gives Western producers something they've desperately needed: revenue certainty. It helps them attract private investment to build these expensive plants without constantly fearing that China will just dump cheap material onto the market and bankrupt them, like they did back in the 2010s. Okay, let's circle back to the actual commodity price, NdPr oxide. It surged 40% this year, settled around 67 kilolambs recently. With this $110 floor now in place, what are the forecasts looking like?
Well, industry analysts are expecting NdPr prices to climb significantly from here. They're projecting maybe $75,000 per ton. That's 75 killers in 2026. But, and this is important, if supply stays really tight, we could see potential spikes. Maybe up to $90,000 or even $120,000 per ton late next year or early 2027.
What would drive those potential spikes? Why such a wide range?
It comes down to the gap between that surging demand and how fast new supply can actually come online. The market for NdPr tipped into a structural deficit this year, 2025, about 2,000 tons short.
Okay.
That deficit is forecast to get much bigger next year, maybe tripling to around a 6,000-ton shortfall in 2026. Because bringing new mines and especially new processing plants online is slow and difficult.
And 6,000 tons?
Yeah.
How much is that in real terms? Well, put it this way. 6,000 tons of NdPr oxide is enough for the magnets in over 3 million electric vehicles. So it's a massive hole in the supply chain that can't be filled quickly. This deficit must be fueling some of the success we're seeing from companies outside China, like MP Materials in the US.
Absolutely. MP Materials is a key one. They run the Mountain Pass mine in California, the only fully integrated producer in the U.S. right now.
Mm.
They've got significant DoD backing to expand their processing and move into magnet manufacturing domestically. Their stock performance reflects that up, what, 356% year to date?
Incredible. And outside the US, you have Lynas Rare Earths. They're the biggest producer outside of China, and they hit a really crucial milestone this year. The first commercial production of heavy rare earths outside China in decades at their plant in Malaysia. Why are the heavy rare earths so important?
Things like dysprosium and terbium. They're much scarcer and even harder to process than the light ones like neodymium, but they're essential for high-performance magnets, especially ones that need to work in hot environments like EV motors. So getting non-Chinese supply of those is strategically vital.
And we shouldn't forget recycling in all this, should we?
No, definitely not. Recycling is becoming an increasingly important part of the picture. It won't solve the sheer volume problem on its own, but it's a vital complementary source.
Are we seeing progress there?
Yeah, innovation is improving recovery rates.
Mm.
They're up maybe 50% from electronic waste compared to, say, 2015. And you're seeing real efforts towards closed-loop systems. Apple, for instance, has partnerships with producers to recycle rare earths from old devices. It helps improve resource efficiency dramatically.
Okay, so pulling this all together, the core investment idea here seems to be this mismatch, right? You've got massive locked-in demand from EVs and wind this whole electrification mega trend.
Structural demand.
And that's colliding with this really constrained supply situation that takes, you said, a decade and billions of dollars to meaningfully fix because of the processing complexity and geopolitics.
That's the asymmetric setup, exactly. And it's interesting, despite those huge stock gains we mentioned, like 77% for the REMX ETF, up to 356% for MP Materials.
Yeah.
Many of those company valuations still seem to imply NdPr prices below that government-backed 110-kilogram floor price. It suggests the market maybe hasn't fully priced in the durability of these higher prices, especially with that government backstop. So there could still be potential upside there if prices stay strong.
Okay, but let's balance the picture. This sector isn't without risks, obviously. What are the major things investors need to keep in mind?
Number one risk, without a doubt, is still China. They have a lot of spare production capacity they could potentially turn on.
The China risk, right?
Exactly. They could, if they chose strategically, flood the market with cheaper material specifically to undercut Western producers trying to get established. They did it before in the 2010s, drove many Western companies out of business. It acts as a sort of potential price ceiling until Western supply is truly large-scale and independent.
And then there's the challenge of actually building these projects, even with the funding. That's the second big one. Execution risk. These rare earth projects are just inherently difficult. You've got the complex separation technology, the whole issue of handling radioactive materials safely, navigating really strict environmental permits.
So even when projects get announced and funded, they often face multi-year delays and budget blowouts.
Mm-hmm.
Getting the money is one thing. Actually building and operating these plants efficiently is another huge challenge.
And longer term, is there a risk that technology just moves on? That's the third risk, substitution. If rare earth prices get really high and stay there for a long time, it definitely incentivizes research into alternatives. Things like rare earth-free motors using ferrite magnets or different designs like copper coil motors. Do those alternatives work as well?
Generally, they involve some trade-offs, usually in performance, size, or efficiency compared to NdFeB magnets. But if NdPr prices become prohibitively expensive for years on end, that could accelerate the development and adoption of those alternatives, potentially changing the long-term demand picture.
So for you, the listener, navigating this complicated space, there are different approaches, it seems.
Yeah, you could look at direct investment in the established producers like MP Materials or Lynas. That gives you leveraged exposure to the commodity price, and you benefit from that government backing.
Or something more diversified.
Right. ETFs like REMX spread the risk across multiple companies, reducing the impact if one specific project hits delays. REMX is up 77% this year, so it's captured a lot of the upside already.
And indirect plays.
You could also get exposure indirectly. Think about downstream companies, manufacturers, defense contractors that are actively trying to secure Western supply chains for their own products.
Okay. So wrapping up, what's the main takeaway here?
I think the core idea is that this isn't just short-term market hype. We're talking about a fundamental structural shift driven by strategic necessity, energy transition, national security meeting a genuine investment opportunity. The supply side is going to remain tight and politically sensitive for years. That likely means elevated prices, and continued focus at least through 2027, probably longer. So it seems the debate about whether rare earths even matter is pretty much over. They clearly do. The real question left for you to think about is this. Can this massive effort, this strategic competition between nations backed by billions in government cash, actually fix the supply bottleneck fast enough? Can they build out this independent Western supply chain before something else changes the game? Like either a major breakthrough in substitution technology or maybe just another big political shift that alters the economics of these critical, indispensable materials all over again.
See you all in the next Pro Ticker Deep Dive.